this video, we're going to talk about density, what it is, and how to solve for it. So let's go ahead and get started. You are going to want to have a calculator nearby, so you can go ahead and move that closer to you as well. We're going to need that at the end. So the formula for density is D equals M over V. D is density, M is mass, and V is volume. This is the mathematical equation. Some people like to set it up as a triangle as well. It's still the same formula, D equals mass divided by volume. Some people like the triangle method because you can cover up whatever you're solving for, and then you can easily decipher which order of operations you need to do. So for example, if D was covered up, you would know you have to do mass divided by volume. If volume is covered up, then you know it's mass divided by density. If mass is covered up, then you know it's density times volume. So it's an easy way to know your order of operations. So what is mass? Mass measures how much matter is present in a substance. We know the formula is mass equals D times V, and the unit is always grams. So anytime you see how many grams or what are the grams, or you see the unit of grams, you know it's referring to mass. When we find mass, you typically want to place the object on a balance and record the mass in grams. You can either use a triple beam balance or a digital balance, whatever your teacher has on hand. Volume is another variable. Volume is a measure of how much space the matter occupies. Volume is mass divided by density. The unit is either going to be centimeters cubed or milliliters. Centimeters cubed is if it's a solid object and you can measure length times width times height, or milliliters if it is an irregularly shaped object or if it's a liquid. So an irregular shaped object would be something like a ball or a person or a pen or an apple. In order to find volume of a regularly shaped object, you want to do length times width times height, and you can simply just measure the regularly shaped object in centimeters. If it's an irregularly shaped object like a ball or a pencil or an apple, you can use water displacement. So with water displacement, you want to fill a graduated cylinder with water, and you're going to place the object in the cylinder. You're going to observe how much the water level changes. So you want to take the initial water level and subtract it from the final water level. So the new water level minus the old. This is very similar to like getting in the bathtub. You could see the water level rise, or if you got in a hot tub with you and 4 other friends, the water level drastically rises. That's the same principle. Here's a quick example. Here we can see that the scuba diver is outside the graduated cylinder, and the water level was initially 3.4. It's going 0.2, 0.4, 0.6, 0.8, and 4, so we know it's 3.4. Once the scuba diver is inside, the water level rises to 5. So 5 minus 3.4 is 1.6. So the volume of the scuba diver would be 1.6. Density is our last variable. It is a physical property relating the amount of matter in a substance to the volume of the substance. D equals M over V. So our units then have to be the same way. It's either grams per centimeters cubed or grams per milliliter. Make sure you use the right one. If it's a solid object, it's centimeters cubed, or if it's a liquid object, it's milliliters. So the density of an object of a substance is often compared to water. The density of water is 1.0 grams per cubic centimeter. This is very important to keep in mind. Anything that's heavier than 1 is going to sink in water. Anything that's lighter than 1 will float in water, which is why some things sink and some things float. Some other principles or other things to keep in mind is hot air always rises and cold air always sinks, which is why the top floor of a building is always a lot hotter and the basement is typically cooler. The same thing with a hot air balloon. When air is heated, it becomes less dense until the balloon's total density is less than the atmosphere and the hot air rises. Why do balloons take off in early mornings? Because the air is cooler. If the air was warmer, the air inside could not overcome the external pressure. So same thing. Oil is less dense than water, so it's going to float on top of the water when there is a huge oil spill. And same thing with volcanoes. The magma is more dense inside, and then it erupts, and then it's less dense, causing it to sink and overflow. So let's do a few practice problems. Let's decide whether something will sink or float in water. What's going to happen to the following? A piece of wood with a density of 0.74. It is less than water, so it's going to float. What's going to happen to some milk? It's going to sink because its density is greater than water. What's going to happen to some honey? The density is 1.38. It's greater than 1, so it will sink. What's going to happen to oil? It's less than 1, so it's going to float, 0.91. All right, let's do some math problems to solve for the different variables of density. D equals m over v. Our first problem is, what is the density of carbon monoxide gas if 0.196 grams occupies a volume of 100 milliliters? So let's go ahead and let's fill in our variables and what we know. I'm going to go to my dry erase board. So here I filled in what I already knew. I knew I was solving for density, so I left that blank. My mass was 0.196 grams. My volume is 100 milliliters. So I know that if I cover up the D, it's mass divided by volume. So I'm going to do D equals m over v. I can now plug in my numbers, 0.196 divided by 100. I can put it in my calculator and I can solve. 0.196 divided by 100 is 0.00196, and since it's density, we're going to do grams per milliliter. Remember, you must always have a unit, and then you can circle or put a box around your final answer. I always write my variables, and I always like to write the formula so I can easily solve the problem. Great. Let's move on to number 2. Number 2 says, the density of silver is 10.49 grams per cubic centimeter. If a sample of pure silver has a volume of 12.99 cubic centimeters, what would be the mass? So, let's go back to our dry erase board. Here I have the density. Density is 10.49 grams per cubic centimeter. Volume is 12.99 cubic centimeters. And mass is our unknown. I always like to write down all my variables so I can easily plug it in. I know I'm solving for mass, so I cover up the m, and I know it's d times v. So m is going to equal d times v according to our triangle. So our density is 10.49 grams per cubic centimeter. Our volume is 12.99 cubic centimeters. So now you can multiply them together, and when you multiply them together, you get 136.27 grams since it's mass. So that would be our final answer. Okay, let's do number 3. Number 3 says, a block of wood 3 centimeters on each side has a mass of 27 grams. What is the density of the block? Hint, don't forget we need to find the volume of the wood. So this one's a little bit tricky. It does have an extra step. I filled in what I knew. My density was my unknown. My mass was 27 grams. Now my volume I said was 3 centimeters on one side, and I put it in brackets because that's not my final volume. Since it's 3 centimeters on each side, we need to do length times width times height to get our answer. So 3 times 3 times 3 is 3 times 3 is 9, times 3 is 27. So that will be our volume. Now I know I'm solving for density, so I cover up the D. D equals mass divided by volume. My mass is 27 grams. My volume is 27 cubic centimeters. 27 divided by 27 is 1 gram per cubic centimeter. And that's our final answer. All right, we have one more problem we need to do. Our last problem says, an irregularly shaped stone was lowered into a graduated cylinder holding a volume of water equal to 2 milliliters. The height of the water rose to 7 milliliters. If the mass of the stone was 25 grams, what was its density? So, here we go. I filled in my mass. My mass was 25 grams. My density was my unknown. Now it said the volume went from 2 milliliters to 7 milliliters. So I need to subtract. 7 milliliters minus 2 milliliters gives us 5 milliliters of the object. This was the initial, this was the final. So now I can plug it into my formula. D equals M over V. My mass is 25 grams. My volume is 5 milliliters. So 25 divided by 5 is 5 grams per milliliters. Okay? You can put a circle or a box around your final answer. So, what questions do you have for me? Hopefully you're starting to understand this. I recommend you take some time, do the practice problems, and get better at solving for density.